My name is Brian Bulkowski. I am the CTO and one of the co-founders of Aerospike. We're a database company that was founded in 2008. And we believed that there was a place for large-scale, essentially in-memory hash tables, DHTs, that were highly available and very high performance. I'm going to talk to you today a little bit about some of the fraud detection cases that we've been addressing. The point about Aerospike is that it's a developer tool. I'm not going to solve all your problems with a prepackaged solution, so I'm really talking to the developers in the house who need this kind of database for providing fraud detection solutions as a service or to their customers. And I'll take you through a few of the different cases that we've been using in the real world, people like some of the large-scale payment processors on the West Coast, as well as some interesting retail brokerages. So what is Aerospike? First of all, as I said, large-scale DHT. The pattern that we see Aerospike being used in is one where there's an application server that provides the compute. That's where you're going to put your algorithms for detecting fraud. I don't know your best algorithms or best ideas. What I want to do is provide the data layer for you to do that. Folks who have used Aerospike, a lot of them have been in adtech and a lot of them are here in New York. Folks that you may know, AppNexus, as well as Exalate, which got bought by Nielsen, great customers of ours, as well as a few folks now in financial services that I can't exactly tell you about, as well as some other ones. I noticed Google Compute Engine is here, and if you saw the TensorFlow talk just before this, pretty interesting stuff. We're big fans of Google Compute. We're based in Mountain View, not that far away from Google, and we've showed some interesting numbers about using Aerospike and Google Compute Engine. They seem to have some of the best storage technology out there, and we're big fans. One way to think about Aerospike is we're a faster version of Cassandra, although we're also a more scalable version of Redis. So if you think about cases where you would be using Cassandra, but you've got too many servers, or cases where you would be using Redis, but you know you're going to have multiple cores and multiple servers, that's where you might think about Aerospike. So Aerospike is a distributed database for high availability. You'll just unpack servers or unpack containers. Those will be the server nodes that will have your storage. And then you'll have client machines, as I mentioned before, that are running your own algorithms. And we support all the clients. So let's talk a little bit about what we're actually going to talk about, which is inline fraud detection using the NoSQL pattern. So what I've found in financial services companies are there's still a lot of folks who are thinking relationally and about these kinds of problems in a relational context. Just recently have we really started going into NoSQL patterns. So the most important idea about this is that the individual data that you're collecting, let's say it's IP addresses, I'll walk through that case. So let's say you want to be able to track recent behaviors, recent web page hits from, or recent behaviors in all the IP addresses in the world. That's arguably about 4 billion key value pairs, and you might be taking millions of writes per second if you're a large-scale collector of information. How do you actually do that? Relational systems would have to index and add to tables, and you'd have to have a really good DBA to understand partition management and sharding to put together a traditional relational implementation of that. Another important fact is how you collect this with regard to things like machine learning. Machine learning has the idea of a feature, right? So trying and essentially unstructured data. And so you're going to want to think about the problem not just in the case of a purely structured table-oriented system. And most of the ML systems don't mate that well with SQL. They're more interested in making direct requests for each individual piece of feature data. So let's walk through the IP address case, because I think it's instructive. And again, this doesn't have to do with your risk model. Exactly how you try to figure out what's risky and what's not risky, that's your problem. We just want to be your data layer. Now, a traditional relational person would start thinking about the problem like this. I've got some kind of a unique ID on my table. That's always a great idea. I've got perhaps risk information coming out of a back-end system that has been computed using a Hadoop or a Spark type analytics system. And I'm going to have, say, a fraud score or a potential fraudulent score for every different IP address range. Right, seems like a pretty simple table. And then you're going to do a pretty simple query to be able to pull out all the different pieces of information. The problem with this is then every request and every read ends up being a actual query of the database and goes through the indexing system. So how would we do this in a NoSQL system? One of the keys to database speed has always been that primary key access, getting that one thing by a primary key, is the key to speed. If you actually have to do something like a range query, those will always be a heck of a lot slower. So if you were doing this with a NoSQL pattern, what you would do is you would have something like your key be an IP address range, and you're going to have to go and get first the key of the range, and then that might get you a list of those networks that came out of your back-end computation system. Then you can go and do a second request and get each one of those individual networks. That's a very different way to think about and model your data. And you might say, if you are a SQL person, hey, but wait, I'm doing 2 network round trips. This is going to be slow. I promise you that making 2 round trips of a key value system is much, much faster than doing a range query in the previous example. Key value requests, and we know this from systems like Hadoop, where if it is an embarrassingly parallel problem, in the term of art, you will get extraordinarily high performance and extraordinarily low latencies. Let's take it one step further, though. Let's say you want to actually collect a series of behavior. Now, we're using one of the NoSQL features, which is the feature of being able to have lists and also associated maps within columns. Now, some SQL implementations, notably Postgres, are pretty good at this. The MySQL guys added this as what they call a dynamic column. And so it's not unknown within the relational implementation world. However, NoSQL guys have really pioneered using these data structures directly in the system. So in this case, just it's a little more exploded. Now, for a SQL person, it appears that we are putting behavior and we're putting the data structure in the database, and we're really coding a particular problem for the data structures itself. Now, that seems like breaking the abstraction that SQL is attempting to provide. And I wouldn't recommend this if you're trying to model a business process. If you have transactions and business payments, etc., the kinds of things that will have great lifespan within your business, you want to stick to a relational, well-understood model with a schema. Fraud, I assert, is different because you need to get new data and new algorithms online as fast as possible to go catch bad guys and improve both your false positive and false negative rates and improve your transaction flows. You might want to put in some new data. You might want to get a new piece of data online, new algorithm online, and then actually take it away months later when you find perhaps it's no longer effective. That's the kind of pattern where NoSQL is a great choice because you're not dealing with data that you expect to be super long-term and to have 80-year, 90-year lifespan within your business. The other great thing about NoSQL is it's really built for a lot of new libraries that are focused on things like ML, things like Spark, things like Datto, interesting company. And I was in San Francisco yesterday talking to another startup. All of these guys are mated to just making simple requests out of Java as opposed to making SQL queries. So again, this is a different architecture. Instead of having an application server generating queries, a database, which is CPU bound, trying to figure out all your indexing strategies, and then a storage layer underneath. And oh, you probably have a cache in front of your database, so often a 4-tier layer for high performance. We're talking about a system that's really closer to a 2-tier system. You have a compute tier, which is your application, and it is making much simpler requests of the underlying layer. At Aerospike, we saw this trend emerging architecturally within the big ad tech companies. These companies are the ones who are doing behavioral approximations and behavioral prediction. And they've been doing that since 08, 09, and 10 within the real-time bidding systems to determine ad placements. So I want to talk to you for a few minutes also about the impact of Flash on in-memory databases. One problem that we see with these kinds of systems is they usually need a lot more data that is commonly able to be put practically in RAM. Even though Aerospike is a great distributed RAM database, we also focused on the ability to use Flash. So this particular case is for was a customer request of ours for a West Coast payments and transaction company, and they wanted about this scale. They believed that that was the amount of data that they were going to need to do effective fraud detection within their system. And 300 terabytes of RAM, and then HA replication, you're starting to talk about a lot of power to drive those chips at that point, right? It's practical to buy all of that, especially with cloud environments and scale out, but it's a little pricey. So we've done a lot of work with Intel, but we do work with all the different storage vendors. What I find in general is that NAND flash is faster than your network. Since flash is faster than your network, why use RAM? You can drop your costs and increase the amount of data you have on the front line of your fraud application by using these kind of technologies. I particularly like the Intel P3700. It's one of the new NVMe drives, and we've benchmarked it with Intel doing 1 million transactions per second. That's in and out of a server with a database request, not just buffering up filling a buffer, as you'll see in some other people's. And so getting in and out of an Intel server with a network request and all the way to storage, so it's persistent. We've seen that at 1 million transactions per second and published a benchmark with Intel. In their labs on even more recent firmware and hardware models, we've seen up to 2.5 million transactions per second. But it's not just Intel. This isn't a special purpose device. The P3700, great device. Samsung's device, NVMe devices are also world beating. In general, these larger companies that have the time and money to spend on firmware and controllers are doing a great job out there in the industry to provide some really amazing devices. So if you were going to actually go out and buy for your data center, if you're a bare metal kind of guy, there's a variety of different configurations you can buy, and the numbers to look at are things like $2 per gigabyte and $1 per gigabyte. Compared to the solutions of buying things like Fusion I/O cards, compared to doing all-flash arrays, those numbers should look pretty sexy to you. What about cloud? This is all fine for all the bare metal people out there, but probably at least half of you don't have your own data center and you're working primarily in the cloud. AWS, as you know, has great flash offerings. They have their i2 instances, and we've seen great performance out of those. Google Compute, I think, is actually ahead in terms of performance, and they're more scalable because you can put more devices per machine. We have a number of customers working in that. Azure, to be honest, has had some troubles with scalability of their storage subsystems. So for Azure customers, we tend to recommend pure RAM deployments. We've got a lot of interest with Docker. We've been doing a lot of Docker webinars. We have Docker images. There's a lot of sophistication about how you actually put together a proper Docker system, because whether you containerize your data or you have your data as an external service is kind of an open question in Docker right now. We happen to have some ex-Docker employees, and we're happy to have some conversations about that. So in the end, hopefully this has sparked some ideas for you if you're putting together your own service, whether it be blockchain, whether it be something like fraud detection, where you need to put data online, and there's some new services out there, new software available that you might not be aware of. I'm available today. We have a booth downstairs, so happy to engage in any conversations with anyone who's working in this area. And we will be having a drawing for a drone at 3:45 in our booth. So if you saw my colleague Jane coming in and out of the room with a thing to fill out, we have one of those nice AR2 drones. So thanks a lot for your time. Hopefully you have a good conference.